Hi, in this video I want to show you a little bit about how the standard deviation works, okay, between different sets of data. So again, we're not going for anything complicated, so the data sets I've chosen are very simple. There's only 5 data values in each case, just 3 data sets, but you're going to find that the results that we're going to are very interesting and help your understanding a lot more in terms of what the standard deviation actually represents, okay. So we've got data set A, B and C, and here are the formula for working out the standard deviation. The formula I prefer using is that one there. That's the formula of choice for me personally, okay? Just because I find it much quicker. So let's have a look at this. So for data set A, okay, what I'm going to do is I'm going to find the mean first of all. So x bar representing the mean, and that's going to be, add these together, so 3, 6, 15, 25, divided by 5, so that's 5. So it's nice and simple, isn't it? Okay? And then for the standard deviation, okay, so we're going to square the values together. So we have 1 plus 4 plus 9 plus 81 plus 100, and then divide by 5, that's how many there are, and then subtract 5 squared and square root it. That is your recap of how to do a standard deviation. Okay, so square the values, that squared plus that squared plus that squared plus that squared plus that squared, add them together of course, that's what the sum means, and then divide by a number of values, which is 5, subtract the mean squared, which is 25, and then square root everything, okay? So we're going to do that, okay? And this is when you may get a calculator out if you wish. You just type up all of that. So 181 plus 14, okay? Just my quick way of doing those 8 together. Divide that by 5 and then subtract 25, okay? And we'll get the square root of 14. Now you may choose, if you wish, to write it as a decimal, okay? Let's see what that actually is. 3.741 something, but I'm going to write root 14, okay, as a reason for that. First of all, it's more memorable, okay, but it's also more exact. Okay? So for data set A, I've got a mean of 5 and standard deviation of root 14, okay. We might just need to remember that, all right. So I'll just put this down by there for the moment, okay, and down here, I'm going to write these results up, okay, so I hope you can see it down there. Didn't leave myself much room, did I? So data set A, so I'm going to do it like this. Mean was 5 and standard deviation was root 14. That's for data set A, okay? And next I'm going to put in what I'm going to get for data set B. All right? I'm going to rub the work off the board, hope you don't mind. Not that you have any choice, because you can't do anything about it really, can you? Even if you said, yes I do mind. Oh, not here, would I? Right, let's do data set B. Okay, so same again, let's work out the mean. Alright? Now what do you get when you work out the mean of those? Okay, you should get 15. I'm going to take a closer look at that now. Okay, is there any way you could have predicted the mean was 15 without actually working it out? Just think about it. Yeah, just think about it. Right, I'm going to do the standard deviation next, so that is, why on earth did I underline that? That is going to be 121 plus 144 plus 169 plus 361 plus 400. Oh, run out of room. Divide that by 5. Subtract. Yeah, sorry, I've run out of room there. Anyway, let's just work out what those are, okay? So that plus 169 plus 144 plus 121. So divide that by 5. Of course, subtracting from that the mean squared, which is 225. Okay, and lo and behold, I also get square root of 14. Well, amazing, interesting. Okay, that means for data set B, we've got exactly the same standard deviation. Not the same mean, but the same standard deviation. How is that happening? Okay. Time for you to pause the video and just think it over. Why have we ended up with exactly the same standard deviation? And paused it. Good. It's happened because, if you notice, from data set A, okay, all we do to get to data set B, or all I've done to get to data set B, is add on 10 to each of these numbers. Did you spot that? Okay, if I add on 10 to each of those, okay, so can you see that really it's exactly the same data set, just add on 10. Now, what happens if you add on 10 to a list of numbers? Well, the mean is going to go up as well, isn't it, by 10. That's the question I asked you earlier. If there's a way of predicting the mean of B was 15, okay? So just imagine these were marks in a test. Okay, pretty poor, yeah? But imagine these were marks in a test, okay? And the mean mark in those sets of figures was 5, and the standard deviation was root 14. But then I said to everyone, right, I'm in a generous mood, I'm going to add on 10 to your test scores. Okay? The mean goes up by 10, doesn't it? Okay, the mean mark goes up by 10 as well. So the mean mark is 15. The spread of results stays exactly the same. Okay, so if these were 5 different people who took my test, this is the spread of results that they got from my test. If I add on 10 to everyone's mark, because I'm doing the same for everyone, the overall spread of results is exactly the same. Okay, the relative gap in performance is the same. Okay, and that's exactly why the standard deviation is the same. Okay, that gives you a good example of what standard deviation measures. It measures the spread of results. Okay, if you've got 2 sets of figures where they've got the same standard deviation, that means the spread of data exactly the same. Okay, and let's have a look at C. Okay, data set C. Can you predict what the mean is going to be without actually working out? Maybe have a go at doing this. Okay. Can you see what's happened from data set A to data set C? Very good. Just multiply by 10. Okay, multiply by 10 this time. All right. So times that by 10, that by 10, that, and you get these values there. What happens if you multiply every single data value by 10? Well, the mean is going to increase by 10 as well, isn't it? So the mean should be 50. If in doubt, just add them all up. Okay, 190, 220, 240, 250 divided by 5, again, 50. All right. So data set C, mean of 50. That's how the mean works. Okay. Add a value to each data value, then you increase the mean by that value, just add it on. Multiply each value by the same number. Okay, and then the mean just gets multiplied by that number as well. The standard deviation, though, have you worked out what that is? Can you predict it? Okay, well, let's just have a look. I'm going to do it on my calculator. I'll read out, because I ran out of room, didn't I, on part B, so because the numbers are bigger, I'm going to run out of room again. Okay, so I'm going to read them as I do them. So squaring these first of all, so 100 added to 400, okay, added to 900, added to, what's that, 8,100, and added to 10,000. Okay, I get 19,500. Divide that by 5. Okay, I get 3,900. Subtract the mean squared, so subtract that squared, so subtract 2,500. Okay, I get 1,400. Okay, square root of that, I get, my calculator says 10 root 14. You can put it as a decimal if you want. Okay, but the critical thing there is, can you notice that the standard deviation is the same as in data set A but multiplied by 10? And the reason, it's obvious now, isn't it? It's because we multiplied all these figures here by 10. Let me just show you a visual demonstration of what has actually happened. Okay? So here I've got data set A. So I've got my values, which are kind of reasonably spaced out. Okay? In just adding on 10 to all these data values, okay, I'm just adding on the same value, okay, to get these. And they're just equally spaced out. Okay, it's not a diagram to scale. All right, that's data set B. And then data set C, what I'm doing is I'm multiplying every figure by 10. Okay, so this one here, and then this one gets spaced out more. This one gets spaced out a lot more. This one gets. They're all getting, okay, spaced out more, but the relative spacings between them are all going to be by a factor of 10. Okay, hence the standard deviation has increased by a factor of 10 as well. Okay. So in general, if you've got a data value, okay, data set, and you've got a mean, okay, if you say that the mean is x bar, okay, if you add on a fixed number, a constant to each of the data values, okay, your mean is also going to increase by that particular value. Let's just say add on data value, A by data value. If we multiply all the values, okay, then the mean is going to increase by a factor, by a multiple of that. So it's going to be A times by x bar. Okay. The standard deviation, however, if you add on a constant value to each number of the data set, it's not going to change. Okay, it won't change at all. But if you multiply, then yes, if you multiply each value by the same value, then yeah, that will change. Okay. I'm hoping that was useful for you. Okay, I'm hoping that was not only a recap of how standard deviation works using that second formula, but also showing you the differences in values you get for different types of data. Okay. See you later.